Okay, let's start with 10. 3 towns joined by straight roads, 15, 20, 28 degrees. CX to be built from C to join AB at X. Find the shortest possible length of CX. In your diagram, you should have this for the position of X. Do you have it? Shortest distance, ma? So the perpendicular distance. Now they want us to find the shortest possible length of X. The shortest possible length of CX. So like I said, in your syllabus for Sec 2, you need to be able to identify all the important right angle triangles. So here, we have one right angle triangle with the angle 28 degrees. We have the hypotenuse 15 kilometers, and we only have one side. What is this side CX called in relation to 28 degrees? Is it the adjacent, opposite, or hypotenuse? Opposite side, yes. So which Trigo ratio do you think we should be using over here? I've got opposite, I've got hypotenuse, so which Trigo ratio? Sine. So part A, sine 28 degrees equals to CX over 15. So this is the minimum working I must see. Anything less than this, you will be penalized. Now sine 28 degrees is just a number. Calculator, check that you are in the correct mode. Over here I got the letter R over here, so I need to switch to degree mode. Okay, now there's the letter D. So I'm in degree mode. Sine 28.46947. So CX will simply be 15 sine 28 degrees. So I multiply this by 15. I get 7.0420. Round it off to 7.04 kilometers. Angle ACX equals to, how much is it? What is the working? 180 minus 28 minus 90. But what's the reason? Angle sum of triangle. So here I get 62 degrees. This part is 62 degrees. What about this one? This side. Angle XCB. We need to find that angle before we can add them up to find angle ACB. How? So what have I been repeating about this topic for Sec 2? You must find what kind of triangle? Must find right angle triangle. How many right angle triangles do you see? 2 of them. Did somebody say 3? 2 lah. One is ACX, the other is CXB. So that's my other right angle triangle. For this right angle triangle, I've got an unknown angle, I've got a side 20, and I've got CX already, which is 7.0420. This is a right angle. So based on this, which Trigo ratio do you think we can use to link up 20, which is a hypotenuse, and 7.042? What is this side known as? Adjacent. Yes, it is adjacent to my unknown angle. So adjacent and hypotenuse, which Trigo ratio? Cosine. Therefore, cosine, this angle is known as XCB. XCB equals to, so cosine of this angle is adjacent. CX is 7.0420 divided by hypotenuse of 20. So angle XCB is equals to cosine inverse. You can write out cosine inverse, or you can just straight away use your calculator to find out the value. Cosine, inverse cosine. Earlier on, my answer was and we divide this by 20. So I get 69.383 degrees. Add up the two angles, angle ACB is equals to 62 plus whatever answer we just found. And we get 131.4. So question 10 done. Next, question 14. Okay, this one is slightly more challenging. This is a pyramid. So for part A, I have a 50 degrees over here. This is a right angle triangle, and I have a side 8 cm. What is the name of this side in relation to the 50 degrees? The 8 cm, what side is it known as? Is it adjacent, hypotenuse, or opposite? What is it? Adjacent. Yeah, this is the adjacent side. And what about this unknown PQ? Aiman, what is this side? Hypotenuse, good. So, adjacent and hypotenuse, which Trigo ratio do I use? Sine or cosine? Cosine. So for part A, cosine 50 degrees is adjacent, which is 8 over PQ. Therefore, PQ is simply 8 over cosine 50 degrees. Calculator, 8 divided cos 50. Let's get 12.445. Round it off, 12.4 cm. Since VR is vertical, I am now going to draw the triangle VRQ. You tell me whether you try to visualize VRQ first. I'm going to draw it out for you. VR is a vertical line. So V, R over here. And I've got a side Q. Okay, do you agree that this side of the triangle looks like this? VRQ. If R is the top of the pyramid, then VQ must be on the base, right? On the floor. So that's why I draw VQ on the floor. And then VR, according to the question, it is vertical. So you just put your pen, your pencil on the table, vertical. That's what it looks like. Now I'm going to include all the other information that I have. I know that VR is 7 cm. So 7 over here. I also know that RQ is 8 cm. Then the angle VQR is over here. So now you have to form the Trigo ratio again. What are the sides? What is this side RV known as? In relation to the unknown angle VQR. What is RV known as? Opposite, good. And RQ? Hypotenuse, okay. Opposite hypotenuse. Which one is it? Sine. Sine VQR equals to 7 over 8. Angle VQR must now be equals to inverse sine. Just key in inverse sine. 7 divided by 8. You get 61. Round off those. Okay. What happened? So for the recording, the triangle that we are using is R, Q, and V. 7 and 8 over here. This is our unknown angle. So tangent VQR is 7 over 8. Angle VQR is now tangent inverse 7 over 8. You get an answer, round it off to 41.2 degrees. We know that the shortest distance must be the perpendicular distance. So this point over here is known as T. And again, the right angle triangle has appeared on the right hand side. This part with 8 cm for this side RQ. What is the name for this RQ now? Adjacent, opposite, or hypotenuse? In relation to 50 degrees. Because this is my right angle triangle. Huh? So 50 degrees over here, what is this side RQ known as? Hypotenuse, adjacent, or opposite? I draw the triangle for you. This is R, this is T, and this is Q. 50 degrees. What is this 8 cm known as? Hypotenuse. Then I want RT. What is this RT known as? Opposite. So opposite hypotenuse, which Trigo ratio? Sine 50 degrees equals to RT over 8. RT is 8 sine 50 degrees. .128. Round it off to 6.13 cm. So if I draw it out over here, this is R, V, and T. RT we found it to be 6.128. VR is 7. So VTR is this angle over here. And that's what we need to find out. So adjacent and opposite. Tangent VTR 7 over 6.128. Angle VTR, inverse tangent. For the 8.798. Okay, yeah, okay, it's radius because these are circles, so I know it is 3.8. But what is the side of this triangle known as? Adjacent, okay? And my x is found inside the hypotenuse. Adjacent and hypotenuse, which Trigo ratio? Cosine 70 degrees is adjacent, which is 3.8 divided by hypotenuse. How much is the hypotenuse now? 3.8 plus x. One equation, one unknown. You can solve. So 3.8 plus x equals to 3.8 divided by cosine 70 degrees. Then x is equals to 3.8 over cosine 70 minus 3.8. So I like to leave it like this so that I can, I don't have any rounding off in the middle. 3.8 divided by cosine 70. Then I minus 3.8. I get 7.31. Then the last one. Part A, cosine BAC. This part. Adjacent over the hypotenuse. Right, so adjacent is 530 divided by the hypotenuse, which is BA. And we know that since it is a right angle triangle, BA is actually square root of 370 square plus 530 square. And we're only interested in the positive value. Yeah? Okay. Shui, you also need, right? Go lah, go lah. I'll pass it to him. Okay, so square root of 417,800. We put this inside here. 417800. Leave your answer. as a fraction in the lowest term. Okay, so we're not gonna leave this as a fraction. So 0.820. That will be our answer for part A. Then now the angle ACD is 70 degrees. Find the shortest distance from A to CD. Again, draw your 90 degrees down. Shortest distance, A to CD. Then we're going to find our right angle triangle again. There are so many right angle triangles over here. The right angle triangle that we require will be this one. Now, if you are doing, whether you are doing paper 1 or paper 2, sometimes you find a need to define this point over here. Because we need to find the length of AX. So now I'm going to teach you how to write down, how are you going to describe this point X? I indicate in my diagram. I want this point over here. How are you going to describe this point in words? Let the what? Any suggestions? Because they say shortest distance, right? Yeah, I know it is this point that is required. Or then how do you describe this shortest distance? So there are two ways you can do it, and you should be copying this down. Option 1. Let the foot of the perpendicular from A to CD be X. Okay? This is the first option. Let the foot of the perpendicular. This part, the bottom. The foot, your feet are at the bottom, right? So let the bottom, the foot of the perpendicular from A to CD be X. So now we are able to use the side, the length AX. Option number 2. Let perpendicular distance from A to CD be H, for example. Of course, all the X, all the H, you can change to whatever you like. So this is now known as H, without the X. Both ways can work. Area triangle ABC, half times 530 times 370. Primary school student also can do half times base times perpendicular height. So we have 98050 square meters. Oh, this is a very big park. Then we've got another triangle, ACD. How many formulas for area of triangle do you know? How many formulas do you know? One only. You haven't learned the other one yet in Sec 3, which is half times base times height. Right, area of triangle, half times base times height. That's what you all have learned. For triangle ACD, which side do you already know? Yeah, you know AC, right? So do you want that to be the base or the height? Do you want AC to be the base or the height? Base, okay. If this is the base, where is the perpendicular height? AD, good. That means you must find out what AD is first. So we are trying to figure out step by step what we need to find out to get the answer. Now the question changes to become find AD. Are you able to find AD? Which Trigo ratio do we use to find AD? Tangent. So tangent of 70 equals to AD over 530. So AD is 530, tangent 70 degrees. Do you want to evaluate right now? You want to use your calculator and find out what is this value, then you round off and do a lot of numbers? No, not a good idea. So now this I know is going to be the exact value of AD, and I want to keep it that way. Because subsequently, now I want to find the area of triangle ACD, which is half times the base, 530, times the perpendicular height, which is 530 tangent 70 degrees. And now we get the answer. So 0.5 times 530 times 530 times tangent 70, we get a big number, 385,883.2. Then we're going to add this to the area for the other triangle. So we plus. Now the answer is wrong. 98050. And I get total area 483933. How many of you got this? 483933. So you round this off to 484,000. Okay, I don't care. It's decided.